Hello friends, welcome to my channel The Truth of Physics. Today I will discuss the motion of a particle in plane polar coordinates. In this video I will cover the expression of displacement, velocity and acceleration for a particle in plane polar coordinates. So this is our Cartesian coordinate system and this is our plane polar coordinate system. We will find the similarities and contrasts between these two systems. So starting from Cartesian coordinate system, we can see that all these horizontal lines, along each of the horizontal line, x always varies and y is constant. X, as it is the x-axis, so x always varies along the horizontal lines and y is always constant. Similarly, for all the vertical lines, each of the vertical lines, along the vertical lines, x is always constant and y always varies. As you can see that y is always varying, but x is a fixed. Now, what happens in plane polar coordinates? In plane polar coordinates, you can see that these dotted lines are concentric circles. So along this dotted line, the radius r is fixed, but theta always varies. So I have written this. Theta always varies and r is constant. And along these lines, which are radially outward from the origin, this you can see that this makes an angle and fixed angle, suppose theta, with this axis. So theta is always constant along this line, and r, you can see that the distance from the origin to any point in this line always varies. So r always varies. Now we will consider the base vectors. In Cartesian coordinates, we know that the base vectors are I cap and j cap. So what are the I cap and j cap? I cap and j cap are the base vectors which is in the direction of respectively along along positive x-axis and positive y-axis. In the same way, we will introduce two new base vectors for plane polar coordinates, that they are r cap and theta cap. In the similar manner like this, r cap and theta cap are in the direction of increasing r and theta. Now we will find the contrast between the base vectors of polar coordinate and Cartesian coordinate. So we know that the base vectors I cap and j cap for Cartesian coordinate are always in the same direction for all points in the space. So for any point in this plane, the I cap is always directed in the positive x-axis like this, and the j cap is always directed in the positive y-axis like this. But what happens for polar coordinates? Consider two points like this and this in this plane for polar coordinates. Now for this point, you can see that the r vector is radially outward, that is in this direction, and the theta cap is in this direction, towards the direction of increasing theta. And for this point, r cap is towards this direction, and the theta cap is in the direction of increasing theta, that is in this direction. So you can see that for these 2 points, the base vectors r cap and theta cap are not same. So the Cartesian base vectors I cap and j cap are fixed for all points, but the polar base vectors, that is r cap and theta cap, are not constant for all points. From this figure, you can also see that the base vectors I cap and j cap are same for these 2 points, but the base vectors r cap and theta cap, that is this r cap and this r cap, and this theta cap and this theta cap, are different. from here it is clear that the direction of r cap and theta cap depends on the position of the point. But these two vectors r cap and theta cap depends on only the coordinate theta, not on r. So why this? Suppose we have two points in this line R2, that is this point and this point. So for these two different points the coordinate theta is fixed. So only the difference between these 2 points is of r, that is the distance from the origin to that point, this and this. Now for these 2 points you can easily see that the direction of r cap is always in this direction for both of these 2 points, and the direction of theta cap is in this direction for this point, and for this point this is in this direction. So these directions, the direction of theta cap is also same and the direction of r cap is also same for these 2 points. So from here we can conclude that for a fixed angle theta, for two different points have same base vectors r cap and theta cap. So and okay, now we will consider two different points like this but of different angle theta. That is, suppose we have 2 points, this and this, and the distance of these 2 points from the origin, that is this distance and this distance, suppose is same. Now you can see that for these 2 points the angle theta is different, that is, suppose it is theta 1 and it is, so this will be theta 2. So for these 2 points you can easily see that the directions of base vectors are in these 2 directions, and for this point is in this direction. It is r cap, this, and this is r, this theta. So you can easily understand that for these 2 points the base vectors are different. So here the distance from the origin to the point is fixed, that is the coordinate r is fixed but the coordinate theta is varying. So and in the previous case we have discussed that the theta is fixed but the distance r varies. So we can conclude from these 2 cases that the r cap and theta cap, these 2 base vectors depends, the direction of these 2 base vectors depends only on theta, not on r. So now we will find the relations of theta with r cap and theta cap.